Tin plays a role in the examination of pigments because it has been used in a pigment like lead tin yellow that was used already from Renaissance. Then in other pigments, for example in modern art pigment, was used in cobalt cerulean blue. But the role of tin is also important in the production of lake pigments because the tin salts are often used as mordant. Tin 50. The X-ray lines of tin, we start with K alpha 25.3, K beta 28.5, and then we have the L lines at 3.4, 3.7 and 4.1. As usual, we want to have a baseline, so we analyze a cube of pure tin, and the spectrum that we get is this one, where the strongest signal comes from the K alpha line at 25.3, then we have the K beta at 28.5, and then over here we have the L lines. So we have 3.4, the strongest one over here, this one, and 3.7 is the second one, the L beta that we can see. L gamma we can't actually see, at least with this setup. Let's look now at some of the most important pigments that use tin. Definitely we start with the lead tin yellow, so it's a lead stannate, so the red one is the pigment. So we see the peaks of tin, K alpha and K beta, and then we see the peak of lead, while the L lines of tin are not visible because we know they are very weak. In particular, if already we barely see the K alpha, of course we don't expect to see the L lines. Let's see another pigment, cobalt cerulean blue, another most used pigment. It's the blue spectrum. So again here this one is a cobalt stannate. Instead of lead, here we have cobalt. And what we see is the blue spectrum, so the peaks K alpha and K beta of tin, and of course the L lines are barely visible. On the other hand, we have here the peak of cobalt. We do now test a pigment that doesn't have the name tin in its name. We have the yellow lake resida from Resida luteola. Is organic, so is an extract from this plant. When we do the spectrum, of course, so it's the red one, we don't expect to see any heavy element. We don't expect to find copper, tin, zinc or something. But over here you see there is this peak barely visible that is overlapped with the one, for example here we put the cobalt cerulean blue just to have comparison. It seems there is some tin in this yellow lake resida. Regarding the L lines of tin, you see over here the black ones are the lines from cobalt cerulean blue, and they are very visible, quite strong. Of course, we don't see anything when we do this measurement on the yellow lake reseda. So if we are interested on the low energy lines, we can try remember the NOF, no filter setup. Is a method in the tube, basically we don't put any filter, and this approach will increase the signal from the low energy lines. We have here in comparison the tin cube is the black one, and this one is in comparison with now the yellow lake reseda, that is the red spectrum, where now we see this peak over here at 3.4 and this is the L-alpha of tin. Changing the filters in the tube, we can confirm the presence of tin with a nice strong peak over here. This very strong peak at 3.7, this is calcium that is in the paper where the lake is painted, but also is the support, the substrate of the lake. Why there is a tin in Yellow Lake Reseda? Because we know that tin salts can be used as mordant. A mordant, remember, when we have the production of lake, the organic extract from the plant that is soluble in water has to be fixed to an insoluble salt. And we use this mordant so that we can have, from a colorant, we can have a pigment.